Okay, welcome everybody. This is going to be an epic live stream. We're going to show you one of the best humanoid robot demos that's ever been done. You tell us if you think this is it. It is boring, 60 minutes, but if you watch this demo of the first kind of humanoid robot, figure 2, let's play it here, doing packages on logistics, but this is 60 minutes straight. We have Brett Adcock, the CEO, joining us as well. So I'm going to quiet this down. And Brett, tell us what we're watching here.
Yeah, well, good. Thanks for having me on, guys. It's good to see everyone. Yeah, we're basically watching a full hour uncut of Figure 2 robot, basically doing small package logistics. So the task here is we basically have packages, like everyday packages that could be shipped to you, being sent down this conveyor line. We have to be able to identify a package, pick it out of the pile. The first task is to be able to basically orientate the barcode down. So there's on this kind of conveyor kind of to the left here, there's a scanner underneath. So we basically have to make the barcode position down and visible to the scanner. So in the case of a lot of the plastic bags, we have to flatten the bags. You'll see some of that. It's what the humans would do if you see a human on this line. Or a box, we have to find out on all 6 sides of the box, where's the barcode at, make sure that in this case we have to get that label basically down. So the goal here is for us to be able to do this in only a few 3 to 4 seconds at very high 90% success rate. And this is an hour of it, just doing it. We run it today. We ran that whole thing since 9:30 in the morning. Still running today, right now.
Oh wow! This is so amazing. I sound like a broken record. I tell people the same thing every time in terms of the KPIs that I'm looking for. Success rate is right up there, right? Success rate, human to bot ratio in these processes. Also, durability, downtime. I mean, 60 minutes. This is the video that we've been behind the scenes. We've been asking for this video for so long from any robot company. So first of all, Brett, thank you for putting it out. One thing that popped into my head when I saw this was how much training was involved before you were able to achieve that type of success rate on this task to do this video? Can you talk a little bit about the process that you went through to get to this point?
Yeah. Okay. So let me say something at the high level before we kind of drill in on the training and how we got here. One of the first things when we signed this customer, there was an enormous appetite to be able to move small packages around, not just in this use case, but the same packages need to be moved in several different types of use cases that look it's same exact packages, but just different. When looking at this, small packages, like plastic packages, have kind of been the Achilles heel for general robotics. They're actively deforming as you're grabbing them, and they're never in the same state. So you can't code your way out of this problem. There's no amount of heuristics that you can do to do what we're doing here. This is a problem that's perfectly suited for a neural net. So in this case, we have a single neural net. It's a Helix S1 model that's running on board the robot. So we're basically taking in camera frames. The robot's then reasoning, what package to grab, how to grab it, and basically, commanding basically full actions out of the robot. So it's just a really hard problem. I think folks in robotics have been chasing this problem for decades, and to be able to show progress here was just it's honestly feels a little magical. It's quite as you watch it, it looks human like. So then you asked a little bit about how we got here with training. So we have to the goal here is we have to we need basically packages pushed out every 3 to 4 seconds. We have to make sure the success rate's in the high 90s in terms of being able to scan the barcode, and then even further down this line, there's a pneumatic label being shot on, and then we make sure the robot has no faults, interventions, just no issues, just overall. It also becomes tricky because the robot can grab heavy things or push itself off. There's just there's a lot of potential just challenges in general. So there's basically been, like, I would say 2 high-level levers that we've been pulling to make these KPIs work and make this use case work. I mean, the first is like we do everything through a neural network through Helix, and we've actually talked about this. There's a whole write-up we did long form on the current blog on the news section of the site. The person that led this, Louis, did a great job kind of laying out like basically how we got here, and I'll summarize a bit here. The first is we basically made like fundamental model improvements to Helix to be able to basically be able to do this. We detail this out online, but like the high level here is that we're basically using like stereo pair camera images. There's also other things like we have force feedback now into the model, so we can basically like force sensing that's basically integrated into the state input. We have memory, so we have a temporal memory. So we have like several seconds of memory from camera frames that the robot can reason over. This is particularly important because things are changing pretty dynamically, and sometimes, like in a lot of cases, the robot's head will turn to do something, and then like a second ago it might have saw a package, but it doesn't anymore. We used to forget about this. We're like, because the robot was just basically reasoning over the current frame. Now the robot, since it has like basically a perception memory, we basically can understand that there's a package still on the left I need to go get. And we've even seen a lot of behaviors where the package will just like kind of go down the assembly line. The robot won't see it anymore and just like put its arm out behind it and grab the package. So we made, I would say at a high level, we made a bunch of like improvements to the overall, like call it Helix neural net architecture. Other things we've done, we also now, the Helix S1 model is also a larger parameter size model. We also saw a boost in performance there. Across all those changes we said, like, force feedback, temporal memory, larger model, we saw improvements with both speed and performance. Of just like just with these changes alone, we saw the speed go down, which the robot was faster, and we saw the success rate climb. Which is really great. And we have some charts on that on the write-up that Louis did online, and they're great. So that's the first lever, which is like, how do we make fundamental neural net improvements so that we can reason over the the observation data from the robot better to perform the use case. And the good news is for this is that we share those lessons that we like these improvements here are being shared on all Helix, on all robots across the organization. So as we're getting better about reasoning over like camera frames and having memory or force feedback or different size models, like we can basically use those advantages everywhere in our current like other client or other things we're doing here internally, which is like a really important part of this. And the second thing is we saw a lot of gains on just like more data and more training, which is kind of like duh, like you like train up more and put more data in the system. We also saw improvements in speed and accuracy from the model. So in this case, what you're currently seeing now, this is being trained on about 60 hours of data. So like which is also pretty incredible that there's not like it didn't take us 1 million hours of data to get to a point where it can do like human-like reasoning on this like small like basically package logistics line. So those are like kind of the two knobs we've been turning overall. And I think one last thing before I kind of put it back to the group is I just walked out from a demo where we showed this and we hit 3.54 seconds per package. I saw it for 12 minutes continuously. And that was from another improvement we did on the technology side, not like data or like model training. We did on the fundamental kind of like the robot technology side to make those improvements. And another thing I'll say is that if you ever look at like the motions the robot's doing, currently today there's probably about anywhere probably between a 4 to 5 times headroom in how much more faster we can run the actuators than what you're seeing today. So one guy online is like, I sped it up like 2 times. It feels like a science fiction film. I don't see any reason we can't get to like beyond human level performance, and even in this use case in the next 12 months in terms of speed.
Now this was what it was.
I'll ask, is this 80, 90%, 100% of human speed? And then what do you think is the ceiling for this task? And like, how would you go from here to achieving your ceiling if it's 110, 150% of human speed? Like, what will you do to get there? What will it take?
Yeah, and you were playing the old video a minute ago. This you can see how much faster the robot is. Not just faster, but like just the package variety, the type of packages is also seen in there in terms of like new package types that were like flat, like more flat packages, polymer bags.
When was this?
Heavier. This was probably about 90 days ago. So this is 3 months.
No way.
Yeah, we filmed this 90 days ago. We filmed it right when I was working.
This old video was 90 days ago, and you went from here, look how slow it is, just, tentative, to now this. Crazy.
Yeah, it's crazy. Well, it's even faster now. I saw it in the lab. It's materially faster than this today. I saw it today. Also more successful, and it was handling a lot more variety of packages, which was also really cool.
Can we get to that magic? Like, I keep hearing 150% of human speed is possible for a lot of these types of tasks. Do you think it's true?
You asked kind of like where humans at today and where are we going to. So I want to answer one thing. I see a lot online in the comments. We're doing like this, humans are doing this today. These aren't other. So like I just want to throw it out there. Like this isn't like we're making up use cases or something here. Like this is like the humans are sorting this stuff, and so the human rate that we're measuring is anywhere between like 3 and 4 seconds per package. The video you saw there was about 4.05 seconds, and then I just saw 3.54 seconds. The fundamental limitation here will be the ultimate peak speeds that the actuators can operate at. And we measure that on radians a second. You can also think about it in terms of RPMs, but the motors are designed for a peak speed that you basically can't push speed any further than the design requirements here for this. Now on figure 2, we have we're not operating nowhere near the peak speeds that we needed, like not even close. We're probably off by like 4 or 5 times in most cases. So then it's a question of like, okay, we can probably like speed it up, maybe in order of like 3 times or 4 times what we're seeing here. I think we can probably get to like, we definitely feel like now we have line of sight to get under 3. I think we might be under 3 in the next like 30 days, to be honest, 3 seconds a package. And I think, I hope we can be under like 2 seconds a package by end of year, maybe even further. So they'll operate much, much faster than a human. Like even seeing the robots operate, we've done some operations where we've like moved the robot at peak speeds. It's like scary fast. The robots will work faster than humans. And there's nothing besides software that needs to be done to enable that.
And what's the human success rate? It's one thing if they're 3 to 4 seconds. It's something else if they're failing like 60, 70% of the time. Is it high 80s, 90%?
We don't have like we're gathering more data now. The human success rate we see is generally on like roughly like 90% success rate in this line. We've seen new hires be like pretty bad, and we've seen experienced hires be really great. So the problem is it's not just like it's being able to really make sure the label's orientated correctly, and then it needs to be roughly close to center line on this line to be able to not only get scanned, but the pneumatic label needs to be shot on the other side. And sometimes that fails because the package is not orientated correctly. These are things that a robot will be great at because it just like follow the rules and never deviate. So we see about 90%. And these are set up so whenever there is a failure, there's a whole nother line to deal with that and triage that. So it's kind of nice for us. Like we can kind of like get in there. We're like I think we're like 95% much of the work we're doing now, which is like above human. We're a little bit slower than a human. At 4, what we showed you there, we're a little bit on the slower end. At 3.5, we're probably in like the average good human. And then anything beyond that is we're just operating much greater.
You probably should compare it also between the first hour and the 12th hour of working.
Yeah. Well, we also see we see a lot of people just take breaks a lot. Like they're bathroom break, smoke break, food, whatever, get on my phone. Like, it's just like, it's not, it's that really kills you. Robots just, in this case, the robot can be charging the whole time. So you can literally do 24/7 work and never leave and just keep working all day.
And I just want to ask everyone else up there, Brett, you don't answer this. What are the 3 Ds
Dirty,
the 3Ds.
dull.
Dull, dirty, dangerous.
Right. It's not it's an or. It's either dirty, it's dull, or it's dangerous. This is which one?
Dull.
Dull. Right.
Yeah. But
and
guys,
because it's dull, you get what? About 100% turnover in these companies.
Yeah.
So Brett was talking about the new hires. The new hires aren't like once a year. The new hires are probably almost weekly.
Yeah.
Which means if you actually look at the overall average, that's what you've got to be doing better than. You don't have to be doing better than the top human. You have to be doing better than whatever your workforce is able to do over the course of a long time. That's
Scott,
the real KPI.
You don't even need to be doing better theoretically, but I think one of the biggest cynic questions, and it's popped up a few times in the chat already. I can answer it, but I want to give Brett an opportunity to answer it. Because people talk to me about this all the time. They're like, but these FedEx has ways to do this with automation already, or you can use robotic arms that are cheaper, that are more precision level multi-use robots. And listen, I have a strong opinion on why that is a bad way of looking at it. But Brett, do you have any kind of immediate feedback to people that say that here?
I think the media, there's a couple of ways I would look at this. The first is that's not what's happening today. So these are humans doing it today. It's not as if like a robot's doing it. We're trying to replace the robot. That would be super silly. Like there are likely, we think, perhaps millions of people in the US doing something very similar to this exact use case, to be at this point now. Even if you get the smaller companies, they have less money for automation in general. I think the second thing is you can make this argument on everything in and around the world. If you look at any single use case and you say like, I want to automate it, you can find a great automation solution for it. That's the problem though. We need maybe hundreds of millions or billions of robots that are all specialized all over the world to do this. What we're trying to solve is the general purpose version of this, like trying to solve general robotics. How do we get a robot that can do that, but yet do manufacturing, construction, and then make food at home for you and do your laundry? And so we're really working on the body to get there, which we think of the humanoid is the perfect thing to traverse everything a human can. And we're working on the brain. And what's how do we get real intelligence out of the system? And this is a good use case where we're never seeing the same package in the same pile of packages ever. There's some generalization that's happening. There's some level of there's some level of representations that are being learned really well that the robot can overall generalize to. And one of the reasons that we love these type of things is we can start shipping product now and figuring out how to run neural nets, get them out to the world, make revenue, get the robot reliability great, get safety up, get cost down, get runtime, get the reliability of the system where we need it to do. These are things that are going to be extremely important for the right first mover, even for the home. So we think this stuff is extremely important to build these the arsenal of technology that we would need to go from doing this to go from doing everyday things in folks at home as well.
I think it's also important to understand that even in those cases where precision robotics with AI can solve a problem and do this task at 2x the speed of a humanoid, you're looking at a very tiny piece of the global market that actually has the upfront capital and knows that they're going to get the value out of those precision robotics long enough that can actually onboard that type of machinery. And that's why if even today, the current machinery that's available today is not being utilized by hardly any of the commercialized industrialized world, because the majority of these types of facilities are smaller. They have massive issues with capitalization. They cannot invest in that type of equipment. And having a generalized piece of equipment that can do multiple things, that's expandable, where if you do have to close down your entire shop, actually have value a year later because they can be used for a million other things down the street at another company, as opposed to one type of equipment that does one thing that the second you buy it becomes essentially worthless if you have to pivot as a company. And so I just don't think people understand that even today we have manufacturers that are using equipment that's 50, 60 years old because they can't even afford the stuff that came out 20 years ago because it's precision and they can't make that type of commitment. And there's a huge difference with a generalized bot that can do 100 things for you throughout the course of the day.
I think like to add to that too, like the neural nets like really like this like transfer learning that's happening across all these different various things. Like this is all going to pre-training, like all this data. And we're going to train Helix to be better and better at just not only this task, but every future task that it ultimately sees. And like, this is extremely important for neural nets. We've seen this in every other industry here for this. And you just can't get that with specialized robots. They're not going to take advantage of the transfer learning that's happening across these like various different types of activities that the robot's doing. And a humanoid is perfect for that. And in so many ways, it's like the ultimate deployment vector for AGI here because of that reason. So it's like this is going to help us be better at the next use case that we ultimately do in logistics, and the next one. And some of these parallels you'll see for things in the home and even other industries. And so like basically like figuring out how to get the body is one thing that can be general purpose, and then the brain that can traverse all things that the human would do in the real world is what we're working on. And you just can't get that with special use robots.
Yeah, I think I'll go one better than Chris on that. Is like, if you could do this with a one-arm bot and a camera and an end-of-arm tool or gripper, it would have already been done. As simple as that. It would have been done already. So if it's that easy, where are they? It's a hard problem. It's as simple as that. And it's also not worth it because 500,000 robots are sold a year worldwide. They don't sell 500,000 robots. They sell 500,000 robots one at a time. Each one's a special use case. It's just too expensive to be able to do it with a special purpose robot. You need one that's general purpose, that's easy to program.
Yeah, Brett, I think one of the other biggest misunderstandings in this space, because people see videos of all these robots around the world, Chinese robots that came out of a new lab, and some of them look pretty cool. Could you help, because you work with some really, really big customers now that you're starting to engage with. Can you help people understand outside of the bot itself how much other work is involved with starting to transition the largest employers of physical labor to bot labor, everything behind the scenes, the logistics, the fleet management, the processes, like that? It's not just about building a robot in a lab. So it's kind of like the difference of building a really cool kit car, which a lot of people can do. Like you have two guys in a garage that can do that, but building a car company is a totally different beast. And I think people don't really understand what's happening behind the scenes at companies like Figure that differentiate them from this random company with a cool robot that they saw a video of on YouTube.
Yeah, I think one thing that we say a lot here internally that will really help cut through this a bit is Figure's, there's a lot of other like companies out there that are kind of like dancing around or doing box jumps or backflips or running around in the like woods or something, like or running a race or something. It's like we're here to sell work. We're here to sell human-like work. And that's going to be human-like work in logistics and manufacturing and construction and healthcare. It's going to be human-like work in the home. And that means you need output. You need like a robot to go in. You want to speak to it ultimately. And you want that robot to be able to do everything you can say, you ask it to. That's what you want it to do. And you want it to do it fully autonomously. You don't want any human in the loop for this, or it's going to be impossible to scale. So if you have that mentality, what you really don't prioritize is are things in the roadmap that are not that are not axiomatically driving to that ultimate solution. We're not doing box jumps and backflips. We're not dancing. We don't want to sew. We don't want to play the piano. We don't want to do anything like that. It's silly. We want to basically like get in the market and do human-like work and output at speeds and performance we need so that our customers, whether it's a home or it's like, a big logistics company or manufacturing company, see ROI and see value from this automation. And so we've set up the whole organization starting from like basically the vision for the company and the mission where we're headed to the product design and how we how we engineer the actual product itself, like the robot, and then ultimately how we develop the systems and processes to basically deploy that, which you kind of hit on, into market, which is like enormous. We have a whole facility here just for like just for fleet operations testing here at Figure, just to make sure we're really ready on the new software releases out into market. And here's one of our facilities is BotQ, which is right across the street from here. We're basically which is our production manufacturing facility for Figure 3. And we already have Figure 3 robots that have been built at BotQ. And we're working now on, further building out the rest of the building and trying to scale to thousands of robots, which we're really excited about. So I think like if you look at it with that lens, Chris, like there's like we don't really care what our cameras look like or what our hand looks like or like all of this stuff. We need a robot autonomous agent to go out and do physical work, and I think we're not seeing enough of that in the market. We really like Figure here, like we pride ourselves and we think of ourselves as like ultimately how well can our robots do autonomous like use cases by itself and drive ROI to the customer. And we're just not we don't see that in the market. So and then when we walk into the customer site, they're having basically a labor crisis. Like they just can't figure out how to find enough humans. The turnover is extremely high. All of our customers cannot, any customer we talk to cannot figure out how to automate fast enough the things that they want to do. They can't build everything from the ground up greenfield again. There's not enough custom robot solutions that they could put in to really make that work in a timely fashion. It's really expensive. So we really hope that we can be over time this generalizable solution we can put in for automation in both the workforce and the home.
Brett, one of the things I noticed from the data was that the accuracy really improved when you introduced the state history and the force feedback, and that was really interesting. I wonder what kinds of physical improvements that would certainly for this task that you would like to see that would improve this. Is there anything from a physical standpoint that would improve this task? And then the second part of that is my package there is the red one in the back. Can you ask Figure to grab that one?
Yeah, that package is never getting out of there. That's stuck there in perpetuity. Okay, let me think about some of the physical things. We've made some enhancements now to Figure 3 that I think will really like yield dividends even in this use case. For instance, one is we actually doubled the finger speeds from Figure 2 to Figure 3. Much of the limitations we're going to have in speed here is going to be on the fingers, being able to open and close fast enough at high rate. We didn't see that in other use cases we had. We just didn't move the hands that frequently around. You probably won't see that. We saw it. It was that was one. Two is we made like a lot of improvements on the cameras. We actually custom designed our cameras for Figure 3. They're incredible, and a lot of those improvements will really feed really well into some of the neural net architecture that we have for Helix. And also we've made some, I would say, pretty impressive improvements on hands as well. So these are all things I think, what I'm seeing, now, Cern, is like the design roadmap for us is to move through the world in terms of like range of motion and speeds and payloads, or you can think about that in torques, more similar to a human over time. That's the game here. It's not like sitting back and saying, can I do this differently with a claw or 3 fingers or no head, things like that. That's not the game. It's actually opposite. It's actually we've designed the world perfectly for humans. So we are weird. We look weird. It doesn't matter. You can't argue if I see a lot of arguments online about is the human the right form factor? It's the wrong question to be asking. It's just we are who we are, and then we built this whole world exactly to interact with a normal human, non-expert human. And if we're way too short, we basically can't interact with our world really well. And so we basically need over time to make the robot, from the product design perspective, it just needs to be able to have the range of motion speeds and payloads or torques more similar to what we call an average human. That's so we can get as much of the distribution of physical labor that humans do today within a general purpose machine.
If it's okay, Brett, I'm going to spill the beans. I'm going to share what Figure 3 looks like. I know you told me not to, but I'm gonna anyways. This is figure 1 on the left. This is figure 2. Get ready, guys. This is figure 3. Oh, Brett. When are we going to see figure 3, Brett?
Yeah, so we actually have so we weren't like supposed to walk figure 3 for like several more months from now. Like the last, like, you know, to be honest with you guys, the last 2 robot bring ups was like super hellish. We like just nothing worked. Like you know, just like you know, especially figure 1, we had never built a robot as an organization. Like, you know, software, electronics, you know, firmware, embedded systems, middleware, operating system, all the hardware, like, you know, like it's just all new to us. We re-gutted for figure 2, just like it's a full new design. We did the same again for figure 3. But with figure 3, we had a lot of our software, like in terms of like the firmware, embedded systems, Helix, all of it will just transfer over now, which is really impressive. And we got better as an organization. The team's like we're about 300 people now, mostly all engineering here and at the lab. And I bet like figure 2 bring up, we had like 60. So we're bigger. Team's like really impressive. We are now not only walking figure 3. I just saw today, like even early this week, do a full autonomous, pretty basic but pretty autonomous, like fully autonomous use case. The robot was actually be able to do like basically something fully by itself, like on repeat, something similar to what we do here with other robots. We have like a autonomous checkout process the robots go through, where I saw basically figure 3 go through all of that. So I would say we're probably like 2 to 3 months ahead of schedule. We walked the robot in the first like 3 to 4 days, maybe 5 days from bring up. That probably took like 3 months on figure 2. It was just like, I'm gonna tell you a funny story. We bought some like electronics from like, you know, Texas Instrument for one point on figure 2, and it just wasn't working. And I was sitting in the lab with them guys every night till like 2 a.m. We just couldn't get it to work. And we called some few folks that were like, hey, you know what, you need to get in touch with this like small team that's at Texas Instruments, and they're so busy and they're so small, they're never going to talk to you unless you like, you know, unless you're buying like $1 billion of stuff from them a year, or you know the CEO. So I went online. I was like, I need to talk to CEO of Texas Instruments as fast as possible. And I tweeted that out, got introduced like that day, talked to the CEO. We solved the problem within 2 weeks. That was just like, it was like that every day for 3 months. I think we like, from the time we actually got the robot built to walking, we were like, it's sub 1 week on figure 3, which is like super impressive. So we're ahead of schedule. You asked like when we're going to unveil it. Unclear. We want to get the robot to a really good working state before we unveil it. We're not in a position where like, here's the robot, like let's just shoot it out. Like we're a bigger organization. We think of ourselves like trying to set a really good leadership principle for the whole industry. And we want figure 3, which is like the most incredible humanoid robot ever built by humans, to be able to show its like true colors when we get it out the door. So we'll see. Definitely not like this month or next, but like we think over, you know, a short period of time, you know, hopefully, definitely this year, we'll unveil it. But we really want the robots to be fully brought up, you know, at scale. Like we're making a lot. So so I don't know, that's kind of a non-answer for you, but we don't have a certain date in mind, and we're not ready quite yet, but it is rocking and rolling here internally. It's actually, the bear cave is right in the corner here in our system integration test lab. And then the sign behind me says system integration and test, and our motto, it says on there, it's just trust but verify.
I was just gonna ask Brett, what, speaking of the background and the employees, what's the energy like? I mean, you're working on the 3rd version of this. You said 300. I think when I did my podcast with you, you had about 250 people. So yeah. Is it like every day people are waking up and they're just excited to solve this problem?
I mean, Scott, what's your impression of, without spilling any beans? Scott was here. I saw Scott this week. Scott was here, saw figure 3, saw the office, the new headquarters. Like, Scott, what's your view of this?
Well, the first thing, I had a hard time finding a parking space, and that's your new office. So yeah, it's pretty full. And yeah, Brett, I thought we weren't going to bring that topic up, but anyway, yeah, figure 3 is amazing.
He hid it from us, Brett. Scott, come on.
It was. I was supposed to come with him, and we're gonna do another.
That's the unveil. That's the unveil. I wasn't expecting to go ahead and see it, but the funny thing is I don't know what the new figure 3 office. It's harder to get into than the Pentagon, you've got to sign your life away like 3 times, and I didn't read half the documents. I think one of them mentioned something about a left testicle. So I can't be specific about what I said, what I saw. About the only thing I can do is use like superlatives and adjectives. And I think the first thing is that I know this is going to be a very disappointing response, but when you see it, you will not be disappointed. The improvements, I mean, anything that you, let's say, had reservations or didn't like about Figure 2, they're resolved. They're mostly gone. And just to show you how hard it is to say, what do you like about it? I actually asked Brett after I saw it, okay, Brett, tell me, what's your favorite improvement on Figure 3? And he rattled off like 10 different things.
Yeah.
So it's like, it's really hard to say what it is you like the best, except to say that you will be, it's definitely, as Brett has said, it's a step change. And the other thing is, this is clearly the bot you want to scale. This is one that it's ready. It's ready for prime time, no doubt about it.
Yeah, it's incredible, Amit. Like, the robot's awesome. The energy's like through the roof here. Like, I mean, I came into work. I was in work every night this week, late. Everybody's here, cranking. We feel that, there's always a lot of momentum in the humanoid space. Beyond that, though, you're like seeing it. We're seeing it work every day, and it's getting better. Like, we don't ever walk in every week and it's like getting worse. It always gets like, robots getting faster. It's getting smarter. It's getting, it's doing more things now. It can do. That's going to only grow materially here, maybe even exponentially here. So we all feel collectively here we have a chance to really do this. When we started this 3 years old, right? Like, a couple weeks ago, we wanted to go off and build like the next Apple or Tesla, some big, really important game-changing technology. And it was unclear, we're just starting on this 5 years away, 50 years away, 10 years away, whatever. And it's very clear it's right now in turn. So everybody's just juiced. Everybody's ready to go. The team's incredible. We have a culture very flat. Every director and manager here CADs our codes. It's very hands-on. So, and we have we're building a lot of robots now, which is cool. So yeah, it's like the energy's through the roof, and we're grinding now. We're just, a lot of this what it looks like a lot of just like really hard work from here. And so that feels like for a project like this, that it could be a quasi bleed on research. It looks like an engineering problem, which is like really great. It looks like just a lot of hard work and a lot of really good, thoughtful decisions can solve it. It looks like it's that scenario here. So we're just like, only thing we can do now is just work, make sure we're heading down the right direction, and just hit the pedal as hard as we possibly can.
I think when you guys like us to think about robots every day, we all have a dream application in our head. And I'm going to ask you to estimate when you think a robot, yours, will be able to achieve my dream application. Okay, so here's what it is. When can a robot in my house pick up a box from IKEA of a chest of drawers, open it up, take it to the bedroom, open it up, read the directions, and I could say, I want you to put it in that corner with the lamp on top of it, and it's going to go end to end, build it, set it up, come into my living room and say, Chris, it's done. For me, that is my dream. Are we 2032 when that happens? Are we 2035? Like, what year is it that happens?
Yeah, it's funny. Mine's like waking up and just like doing like unloading the dishwasher. So like I want to do that every day. I've definitely done all the kids definitely done the IKEA tour here. It's brutal. I think it's just like the worst experience on human history. Listen, at this point now, assuming there's no like hardware limitations where the robot can't, physically do the actual tasks, we can learn it with data. So, as long as for laundry might be a good example, as long as we get our hand in all the way to the bottom and make sure that we have the range of motion to grab things from there, obviously the robot's too short, doesn't have the range of motion, it won't be able to do it physically. As long as the hardware can ultimately do this, we can learn these use cases. So this is definitely like this decade thing, like in the next probably definitely sub 4 or 5 years, maybe sub 2 or 3. And I think like what you'll see even before then is we want to be doing kind of the more traditional things in the home even quicker. I might do that a couple times a year, and that's pretty brutal. But the everyday stuff of laundry and dishes and cleaning things up in the home, we want to be doing that every day, constantly. And I would say those are probably even easier things overall than putting that Kia thing together. But I don't see any reason why a robot, certainly a robot will be able to read the instructions well. It's a more of a matter of just being able to manipulate in subtle generalities that'll need to be done to be able to plan those actions for the robot. I think those are all learnable things.
This is physical AI. This is neural net first, and I want to show you the demo that I found to be the most mind-blowing. And you can explain to us kind of the neural net that accomplished this, right? Because it needs to know what it's doing. And this is the one I'm talking about. So this robot is working, as we've been seeing. This guy walks up, puts his hand out, bot knows, understands, does it. And is this kind of a learned behavior? Did it just do it on its own? And it's the same neural net, right? You didn't train it per se. Can you explain this? This is just brilliant.
That was crazy, by the way. When I saw that for the first time, I almost dropped my phone. I was like, that's the future in front of us right now.
Yeah, it's crazy. That's Louis. That's who led the project here for this this development work. And he's great. This was learned. There was some of this in training where the robot was handing things to humans, and that was learned throughout the training. And to the extent we stick our hand out and sit in front of the robot, it'll hand you the package if it has it. It's amazing. It'll do it. Anybody walks up and does it, it'll do it. The robot now will even raise its hand up if it needs more packages or more help around it. So, watched it. We're operating on these new chutes that have packages that need to be pushed down. Mm-hmm. And the person up top puts all the packages in and pushes it down, and these very large chutes. And the robot needs more packages, raises its hand, and then you just put more packages in front of it. It's unbelievable.
There was one part of this demo where the bot looked like it was thinking, and it goes, "Oh, what am I supposed to do?" And it was so cool. Yeah, sorry.
Yeah, no, I mean, one thing you see, it's not perfect too. We made some mistakes throughout the whole thing. But what we're seeing is those mistakes, they're coming down asymptotically with more data and more training. The robot's basically just out of distribution, and it's just a matter of more data fixes all these things. But for the most part, the robot just works pretty nominally the whole way through. It looks in some way it looks like a human suit, right? It's it's crazy. It's got human type gestures of patting the polybacks down to read them. We want to be able to interact with humans really well through both speech to speech reasoning, but also in this case, if humans walk up and want certain packages from the robot you should be able to point, or you should be able to ask for things, and the robot should be able to hand you those.
Brett, at this point, what kinds of breakthroughs would you be hoping to see? Would it be to do with maybe simulation and training? Would that be helpful? Or I'm just curious as to what kind of breakthroughs you would wish for.
Yeah. We have some things we're working on that we think are going to be really important. Trying to figure out the right way to answer this. Most of the roadmap work that we need, that you would think of closing the gap to being able to ship billions of robots, are all going to happen here on the learning side, on the AI side. And I kind of always think that you have these 3 buckets of technology here on the product itself. You have the robot, the overall hardware that has a lot of stuff in it. It has actuators and batteries and wires, and we have well over 100 PCB electronics boards on the robot. It's got CPU, computer, GPU, has lights, speaker and mic, all kinds of things on it. So you have that hardware. You have there's software there that needs to run on it. You have low level firmware living on the motor controllers. You have embedded software. You have operating system. You have middleware. You have some high level hardware abstraction layer. There's a lot of kind of like C++ living on the robot that would need to like ultimately, help with computation and things like that, both at the motor level and at the compute level. So you have like that side of work that's like it's like non-trivial. It's like really quite hard. We've like mostly vertically integrated all that work here. And then you have like the learning part, which is like kind of maybe you think about like the brain, like how do we get the robot now to do stuff we really need? I would say at this point, like if you had to like make a generalization or like make a statement here, I would say you like the only limitation we have is on the learning side, and then from there, like the only limitation we really have is like how do we do like at scale data collection, and because the robot was doing like BMW manufacturing work before. It's the same robot that was moved over. 90 days later, it can do this stuff now with small package logistics. Nothing changed. We didn't change any of the first two, right? Helix didn't even we improved Helix, but like we used the base architecture when we were first training it. But just the only thing that was an input there was just data. 60 hours of data flowed into it to Helix. So the beauty then is like, okay, how do we need training data? The best thing we have going for us for a humanoid is we have like we're like basically we want to learn from humans. Like it's pretty simple. Like we look like a human. We want to walk like a human. We want to grab things like a human. We want to do human-like things. So humans are our training set. And the goal is like how do we capture that effectively and scale that really well? So we're spending a lot of time on that problem now internally. And like a general robot arm doesn't have this luxury. Like the transfer rate from like a 7 DOF tabletop robot arm is not good from like a human. I mean, you can do human demonstrations for it, but like it's really tough. The transfer rate, like the efficiency transfer from like a human to humanoid is like perfect. It's like as close to perfect as you can get. It's like we have like a human form. We're 5'6" for an average human, so we have arms and legs and hands just like a human does. So so that's what's really crazy is like the only thing that changed from doing that is just 60 hours and more data came in and did that. And theoretically you could do that in sub 3 days. You could have that up and running. I mean, you could parallelize the collection and you can maybe do all that same work we just did in sub 24 hours. Maybe like you have to do training. So maybe like, within a few days you could get that spun up. And in that case, we think we can ship, over time, you'll ship millions of robots to do like small package logistics like that.
Yeah.
So, so unclear the bottleneck is like manufacturing, like data collection here at scale. It really depends on your like go-to-market approach too, and how many different use cases and what type of scale you really want. Like most of it, like I would say it's on learning and manufacturing are the two big areas that you really need to get right over the next 5 or 10 years.
Brett, what keeps you up at night in the supply chain as far as being able to scale to millions of bots? Is it people ask batteries? Is it magnets? What is it?
We get this question all the time. Like we literally have no supply chain problems right now for Figure 3, like zero. We don't have magnet problems. We don't have any problems besides like, we got ripped off and paid like 230% tariffs for a while, overseas for some of our parts we had from Asia. Beyond that, like we have like no supply chain problems. We've designed Figure 3 to be like we designed the supply chain and we designed the manufacturing processes for extremely high rate. Like the Figure 3 head in the Baku video was like an injection molded head. I think that line is capable of doing like 50,000 units a week. Just that line there. It's the same.
So you don't have any critical components you're worried about, like, the planetary roller screws. You don't have that. Is there anything similar to that in Figure 3?
No. I don't know where it would break at. It's certainly not at 1 million. It's certainly not at 10 million, but it could break higher than that, but you'd have so much time to fix those before you can manufacture that many volumes. We have no supply chain problems. We could, that's just not the limiter. We have no issues there today.
This is exciting. This is real. It's happening. It's really freaking happening.
Yeah, I think that there was one part of the video, as the robot got a little bit flummoxed trying to figure out what was going on. Do you want to sort of address that and what was going on and how you're thinking of fixing that in the future?
Also, I'm happy you guys left that in there because it really did feel authentic to see the mistake.
Yeah. I mean, yeah, the robot, we see these like I saw these today, like 90 days ago, the robot's basically out of distribution.
Yeah.
Based on its like proprioceptive state and its environment. It's just it's like not sure what to do. And it's a learning problem. It just needs more data. And the reason the success rate and speed have been climbing is because we have like less of these that are happening with more data. And this is just a data thing. The robot's just data starved. It just needs more data to solve this. More data fixes that problem. Now
you see it starts picking up. Once it gets through that bottleneck, whatever it is that kind of confused it, it just goes right back to normal speed.
Yeah, totally. Yeah, I think this is a data thing. The data will work all those out. You won't see those anymore with enough data. I mean, it's 60 hours. You want to be collecting and deploying robots into like hundreds of thousands of hours. You know what I mean? Like it's just like we're at the tip of the iceberg in terms of like how much data we would want for this, at real scale. So like we feel extremely confident. You'll see all those approach basically zero with more data. You just need enough data for the system.
Can you use this as data to help the robot train itself?
Of course, it's what it's using. Like as we deploy, that's like what you want, a fleet of robots going out, gathering data, gathering good and bad data. Things are going good and wrong, and you want to be retraining on all this.
So it is helping your data flywheel then. It's not like you have to go back and keep on teleoperating everything. When it figures out what the solution is, you're now feeding it back in there, and it's just improving the net.
You want the whole fleet of robots to be taking all this data back into pre-training. Like, like there's, that's the game. You have all these model traces that are happening and, getting better over time, and you want to bring these back in. And, so this is why it's so powerful for a humanoid robot to get things out to the world that do useful things at scale, because the robots will be getting smarter and cheaper. And we've never really seen anything like that besides humans in the world. Like our computer or phone, things like that. They're not getting smarter over time. They're certainly not getting cheaper. It's like making it more expensive. But humanoids will be becoming cheaper and smarter. And it's a situation where you don't want the dumb employee at work or in your home. It's dangerous and it's not great for ROI. You're gonna want the smartest robot. The smartest robot will also be the cheapest robot, and that'll be the group that can get robots up to scale. That's the plan. That's the winner is like who can hit 100,000, who can hit 1 million units in the market as fast as possible. That's the winner, and that's a first mover advantage. And speed means everything here. So, you want to be making, for every year of progress, you want to make an equivalent of like 3 or 4 years to other groups. And that's why we're pushing pedal to the metal as hard as we can now, is because we have a path now to really ship a lot of robots. So we're just trying to make that happen as fast as possible.
And Brett, you think the AI training across a lot of other companies that are in the space inevitably will become the same, which is why you're focusing on first mover advantage? Or do you think there will be a unique difference that Figure has over all of them, along with being first?
Oh yeah, I think you need so a few things you need right now. You need hardware. Like if you had great AI, you can't put that on a Chinese robot and put it in the US. It's not going to happen, or Europe. And you can't put it on a Roomba to make your coffee. So what are you going to do if you have great AI? You're screwed. You'd have no distribution. You need hardware. And the hardware, worse. The hardware is high dimensional, extremely complex. Everybody that's ever tried to do it's failed in the last 30 years. So it's like the hardest industry, maybe one of the most top 5 most complex pieces of hardware humanity's ever built, and you need it. And so you have to get the hardware. You have to get the AI needs distribution. You have to get distribution. You have to solve that. And it's got to be cheap. It's got to always work, and it's got to really never fault or fault very little. And it's got to be able to run the neural net on it really well. And then you got to solve the AI stuff really well. And this host, this vessel, and the AI, they need to be co-designed together.
Hmm.
The way you design the hands and the heads and the observation space of the models, and the data being collected on like in domain for the robot need to be tailored to each other to make the AI run really well. Like AI is not going to run well on shitty hardware, if you put it that way. It's just not going to work. You can't make shitty hardware really great, or even mediocre hardware for humanoids.
Right.
Humanoids are are like tiptoeing this line of, if it doesn't work very well, it doesn't work at all, because we're balancing, we're moving so fast. Like if you think about every joint as like has like 40 joints, they can all spin 360 degrees. It's it's like 360 degrees to the power of 40. There are more states there the robot can be in than atoms in the universe by far. So it's a really tough technology to control. It's a very dynamic. The dynamics of it are really tough. So you need the AI really well right. You need the hardware really right. And then another thing is, like, we're just not seeing other groups do that well, like for long periods of time. We're not. It's a really hard problem. So I suspect there'll be like one or two groups, maybe one or two groups outside of China that can really figure us out. And there'll be a couple groups in China that can really figure us out, and that'll be it. It's just too difficult. And people think this AI thing's a commodity and they'll put on any hardware. It's just a fool's errand. It's just the wrong way to look at things.
Guys, Brett's given us twice as much time as he was supposed to, and I don't want to make him have to excuse himself. Brett, we really, this is awesome, man. Like this is what this industry needs, because like we just really need to get out there and just have real conversations about this stuff, and not being promotional, just talking about what's really happening behind the scenes, because there's just a lot of misinformation out there. And I think people are totally skewed with, what they think is important in this space. And I think we've cleared a little bit of that up today. And man, that video was awesome. Next time it should be 3 hours. So yeah. We might be the only ones willing to watch it, but we will. You can put out a 20-hour video and we will watch it end to end. It was a really important piece. I want to state that if you're watching this and you don't understand how important this was, the difference between putting out a 30-second video clip and a 60-minute video clip is like in a different universe. So thanks for putting that video out. I think it did a lot for the sector. And hopefully this is not the last one we see like that.
Yeah, no, like, thanks. You guys are great. So thanks for having me on. We'll keep pumping these out. We'll keep pumping out more stuff. We're just trying to, we're trying to run it as hard as possible. So this is just the beginning. Like, things are, I saw this weeks ago. We got a lot of stuff cooking. So yeah, I appreciate you having me on. I do have to run right now, but yeah, I appreciate you guys being here to kind of like convey to the world, like, what this looks like. But this is coming. We're excited to keep building, and yeah, appreciate you guys like helping to kind of educate the whole industry.
Dude, let me just tell you, you've got a lot of people that are excited. Every day I'm getting questions. I'm sure you guys are as well. Figure, what's going on with it? Like, people are really following your journey, and it's incredible to see.
That's great. I mean, we really came out with like a kind of like direct to consumer, like almost like building in public for Figure. So we really don't go to press and stuff. We just try to like really tell the story. And I think it's just good to hear that. And since and that's been building, which is great. And hopefully we can bring everybody along for that ride here into this and be super transparent. So anyway, all right, I got to run. Thank you guys for having me on. It was a privilege. Talk to you soon.
Thank you, Brett.
Thanks, Brett.
All right, bye.
You guys want to have final words? Scott, what's your thinking?
Well, yeah, again.
I actually got to go because it's my dad's birthday, so I got to get out of here.
Thanks, Amit.
Okay.
It was awesome.
Thanks, Amit.
Thank you, guys.
Yeah, just final words, yeah.
I think sort of like, what Chris said there at the end is we've been waiting for a full video, a really long video that you can really see the robustness of the system, because anyone can do some operation for 30 seconds, 40 seconds with good video editing, make you believe it was able to do a lot of the other actions in between. So this is something else, to see something from a single point of view running nonstop. Because that's part of the key performance indicators. It's not that can it do the same job as a person, but can it do the same job as a person for 8 hours straight, and then do it the next day and the day after that and the day after that. And this is something that Brett has talked about numerous times. Is like, their hardware, they're not having any hardware faults right now. At BMW, the only faults they're having are really software issues, and they're getting rid of most of those, but the hardware is not failing. And that's very, very, very important. So overall, you know, it comes down to my KPI has always been, can the robot do useful work? And
So
useful
Scott,
work really means it can do it for a long period of time.
Scott, let's talk about that. We have
Mhm.
Brett talked about this. Success rate is a huge KPI.
Yes.
Speed is a huge KPI. Okay. Downtime. The downtime is different than success rate. So, you know, because we don't know yet how in a 24-hour cycle, you know, how many times does the bot itself just break down or have some sort of issue? And it's okay for the CEOs not wanting to be open with the public about where we are there yet. And then also durability. So if you have a bot that, let's say you could make a bot for $30,000 that competitor B has to spend $45,000 on the same bot. Well, that sounds really good unless the $45,000 bot has a 5-year lifespan and the $30,000 bot has a 2-year lifespan or 18-month lifespan. So the durability of the bot. So these are all really critical KPIs, and these KPIs are just the bot themselves, right? But again,
Mhm.
I don't think people are really even talking about this. Obviously, we do. You know, we make huge investments in the space. We analyze it every day. We're engaged with the various leadership companies in the space. So, like, this is normal for us. But when I see people on YouTube, on X, and they're making comments, like, I'm starting to realize how far off the general investor world is. And this is not just retail investors. I deal with massive institutional investors, and you guys do too, that are trying to kind of gain insight into the space. They don't even understand what the KPIs should be that people should be paying attention to. So hopefully doing episodes like this will help kind of educate some of the investor world on what they need to be looking at going forward in order to like rank the companies. And listen, we all have relationships with various robotics and humanoid companies around the world. People ask me every day, like, who's number one? Who is it? Optimus? Is it Tesla? Is it Brett? Is it Figure? Is it Aptronic? Like, I'm like, guys, I don't know. I'm knee deep in this world, and I'm at least 12 months away from having enough data on those KPIs across the spectrum of all these companies to even think about saying, hey, here's your number 1, 2, 3, or 1, 2, 3, 4. Like, we're just not there yet, but you have to know what to look for, and you have to give Figure some credit. This video goes a long way in terms of like showing there's validity in the platform that Figure has built over the course of the last 2 years, because there's been a lot of questions, right? Like, people don't like
Yeah.
up to this point, there's been a lot of short videos, a lot of speculation, but there hasn't been a lot of meat. This is like the immediate video we've seen.
There's bots doing parkour and backflips and everything else, and you know what they're missing? Hands. And that's the name of the game.
Whole nother
That's
thing,
what
yeah.
the whole bot's about. So everyone's looking at what's going on now and saying, well, wait a minute, it can't do useful work without hands until we start seeing that. So this is really, in some ways, they've really lowered the bar, because this is like the most boring of all the videos that are out there. We want to see people lower the bar even more. Give us a 2 or 3 hour video of your bot doing some task nonstop, reliably, so we can get an idea. Can it do it? What's the success rate? What's the speed like? Is there a failure rate? And the other thing we need to know a little bit about is, you know, like you say, downtime and repair. This is a joke I made a lot of time, you know, the bot of Theseus, that if you have to keep on replacing the actuators in your bot after a year, is it still the same bot? So you want to make sure that you actually have robustness. Now, with these bots, it's a little bit different. Industrial bots, they had a hard time when they were putting them in. Everyone's afraid that bot goes down or that robot goes down. The whole line goes down, and everyone's like panicking. It's like, if that is not running, the whole line is down. So you had to have really high uptime and everything else, a lot of maintenance, because you couldn't just swap the bot out and do something. With these bots, maybe you can, but still, you want to make sure the line is not compromised because one of them goes down.
Even the example you just used has nuances to it, because if bot company A has an actuator, if both the bot companies have actuators that go down every 6 months, if bot company A takes an hours to replace that actuator and it's very expensive, where bot company B can exchange an actuator in 2.5 minutes on the line, right? Like just literally can pull that off with an actuator that's actually reasonably cost efficient. Then, you know, bot company B might have a solution where it might not matter that much if it goes down if an actuator goes down every 6 months, right? So like there's just so many nuances to this story, to this industry sector, and we're so early and we're all learning. All I have to say is like, it's early. It's early.
Yeah.
Like I know we're accelerating, but we're still learning what these things are capable of. And man, I still have 1,000 more questions and answers on all of the big bot platforms out there, right?
Yeah.
And I know,
But
Scott,
also,
you're the best, because like you get in these places and you just disappear. You're deep in what I've seen you at one of these. You're in with the engineers. Like you're just, if they don't watch you, you don't leave. Okay, you just won't leave these companies because you're so inquisitive and you actually know what you're looking for. So I like it when we do these site visits and I could just kind of stand behind you and listen to all the questions you're asking. That's how I learn on this stuff.
What's going to be interesting is a lot of these bots already have a certain amount of built-in redundancy, and we all know that, you know, if we sprain our ankle or knee or something like that, we can still keep kind of going. We just kind of push through it, something like that, and at the end of the day, we're all right. So it's possible the bot could be sensing that, oh, one of these actuators is going to go down, so I'm going to take a different way of doing a job. I'll slow down a little bit, but you're going to know about it, but I'm not really going to compromise everything until someone can come in and do it, which is a lot different than an industrial arm, because you lose like one axis on one of those arms, it can't do the job at all, period. It's down. So there will be, you know, it's going to look like one of those heroes in an action movie, you know, gets shot, he's limping along, but still able to do the task.
Well, guys, this is exciting. Thanks for putting this together. And it's been so fun for me to get to be part of this. I have to jump as well right now. I have a family commitment I have to get off to, but this is great.
Perfect. Hey, thank you, everybody. Appreciate you. See y'all.
Yep.
Thank you, guys.
Same here. Yep.
Bye.
Bye.